Then let's start. So thank you, and a warm welcome to my session about the data architect's journey from Power BI to Microsoft Fabric. I said before, if you have any questions, just put them into the chat, and we will have time between the two sections to answer questions. My journey with Power BI started actually as a student working at an industrial company. And the goal back then was quite simple, automate a few repetitive Excel task reports. And to be honest, I had no prior experience with BI tools, and no one around who could help me. So just like, hey, Max, we have a tool, we have Excel files, why don't you try out? So I just started experimenting, learning by doing, and trying not to break too many things along the way. And well, at that point, I had no intention of working in BI, to be honest. It really just started as a small side task, but one thing led to another, and it gradually turned into a passion and eventually a profession. And looking back, this unexpected start, I would say, became the first chapter of a longer journey in my career. One that took me from simple self-serve reports to full-scale data architecture with Microsoft Fabric. And let me walk you through the key lessons learned, challenges faced, and milestones reached along the way. In stage one, I called this beginning the journey, aggregating Excel spreadsheets. As said, this was my very first task. And the problem that led to this project was that the manual consolidation of Excel files via copy paste was very time consuming. It was carried out by a lot of people redundantly. So I used Power BI with the SharePoint connector to automate the report creation. As you can see here, I had different folders with a bunch of Excel files. Some of them had the same format, others were the special, so just one file with that format and that information, but then some files that had the same format but just contained information, for example, from different countries. Once this setup was developed, it required frequent troubleshooting, meaning that the format of the Excel files was not locked. So whenever a user changed it, I had to either correct the Excel file or Power BI. So it was semi-automated, no longer manual work, but very fragile. And even despite these early issues, it was a big win for my users because they had a huge time saving because they no longer needed to do all these consolidation manually. And they were happy that they finally had one single source of truth. So these benefits, was I think the reason why they showed a very high tolerance for errors in this early stage. I was then quickly asked, still considered this stage one, I was quickly asked to replicate the solution in a different subject area. It was not 100% the same setup on the SharePoint, but a very similar one. So I was able to replicate most of the work that I've previously done and build a second report based on this new SharePoint. And the technical setup, still manual interventions required. Lots of mornings where I came to work and discovered that the scheduled refreshes of the reports failed during the night. So the first 1 to 3 hours were just fixing them. So I would say that the success in that stage did not come from the perfect architecture or implementation, but from solving real problems. And I think this is the power and the challenge of self-service BI, that you can deliver value quickly, even with the very fragile setup. But then the challenge, if the value is real, people will want more. And this was also what happened in my case. In the second stage, first real integration, combining files and databases, I first adapted, and this was my first architecture decision that I made intentionally, I would say. I adapted the two manual setups to make the data reusable across reports using the two, let me highlight that, the two data flows here that I've implemented. Second is that I integrated data from our ERP system, also make it reusable using a data flow. And then I've built a new report based on all three data sources. And this way I was able to expand my user base by providing more comprehensive insights. The benefit for the users was that, again, they didn't need to compare all the three data sources manually. Yeah, again, had for this comparison a single source of truth. However, there were some concerns at that time because building this third report took me quite a long time because I still had little experience with Power BI and also no real BI project experience. So it took me time to figure out technical things, how to solve this, how to build the queries, how to best way to arrange the visuals and so on. But also did that in a quite, from the point of view today, inefficient way because I didn't have my BI project structure in mind. I just started, experimenting. But still, I received very positive feedback, highly positive feedback, because this data comparison was finally automated and saved my users a lot of time. And also then they didn't need to look at things in ERP system, that they're nice and shiny reports in that. Stage 3, keeping up, meeting new demands with existing methods. Here, as you can see, I integrate additional sales data sources. For example, here we have more data sources within the ERP system, but also integrated Salesforce as our CRM system. And new data flows and new reports, new users. What you can see here, and it starts getting a bit confusing, is all these arrows that we have here. Still integrated the different data flows per report. So in each of the reports, semantic model, data set, how it was called in Power BI back then. But this repeated integration efforts led to new insights and improvements in my data techniques. So whenever I finished a report, I learned something new, and I was able to implement that or some improvements into the existing reports. So some code snippets I exchanged because the new one was bringing a lower risk for errors, or the refresh time decreased over time as I was able to build the transformations more efficiently. So this, what I would consider overhead from today's perspective, doing the integration over and over again, back then was helpful, I would say, because it helped me to gain more experience and improve the technical setup in an iterative way. My users still continued and totally appreciated the reports. They were happy with that, but it started a bit to merge some confusion and overlap between target audiences and report the use cases. So for example, you can see here this report had then two user groups, slightly different requirements. This group of users here, they were using, based on this initial Excel setup, one report, but the data also went into these reports. So the questions from this group here. So with sometimes some questions, a bit confusion, but not critical at that point in time. Everyone was still happy with having this reporting. This also continues, so the people saw value in that, and of course they wanted more. So there was in stage 4 growing pains, repeated integration of every report. Sounds bad, but the reason for this is that there was a demand for more and increasingly specialized reports, and this demand grew and grew and grew. So they saw value in that, they wanted more reports, and the benefit also shifted from simply automating repetitive tasks to really providing new insights. This was made possible by leveraging completely new data sources that haven't been used in a manual way, but which I then identified and integrated into the reporting. However, the data integration, as you can see, was still implemented separately for each of the reports. And to be honest, learnings from building these additional reports started to decline. Yes, I fulfilled my users' requirements, supported there in their daily activities, took manual work from them and provided new insights by using new data sources. But for me, in my professional growth, doing the implementation over and over again, did not bring any technical new learnings for me. So the benefit of doing this over and over again clearly declined. And at that point in time, I would also share today's view that the integration efforts became mostly repetitive overhead without any added value. To stress this even more, let's add some new data flows in here, data sources and reports. And I think you all see that this looks quite complicated, right? And more I realized, and then we go to stage 5, that there's a need for a unified data layer. And there are two main challenges they had, and from which I saw that the requirements and user expectations exceeded my architecture's capabilities. Multi and red is one data flow coming out of the CRM system, and through other data flows like here or directly, it went into 7 different reports, which caused a consistency issue. Because minor differences in refresh timings or KPI calculations led to a noticeable inconsistencies. So maybe the reports here were updated earlier. Maybe there was a delay caused here because of the other data flow refresh. And with people having, as you can see, this is a very user group with a lot of reports they used. As these reports all answered slightly different questions based on the same or similar data sources, it was not rare that they had multiple reports open at the same time. And they noticed that probably or maybe the data in one report wasn't up to date, or during a report definition, we decided to, or they requested to, or even bad, another user group requested different KPI calculation, which all led to some kind of inconsistencies, which are a threat to the trust of the users in the system. And the second issue that we had is that users underestimated the required time for new developments. As you can see here, this is one of the reports that was new in this stage. There, from the arrows marked in red, you can see that I needed to integrate 4 different data flows, which don't know if that exact combination exists somewhere here, but I've done this before, these data sources. But from the point of my users, it was just, hey, can you build a new report with this data sources answering these questions? And for them, it can't take long because data is already there, right? So they thought, okay, you just need to arrange it a bit differently, and that's it. But for me, very often it was developing all the integrations again because they had their special requirements that were not part of the previous one, or they want to have one additional data source to the 3 existing ones. So I did this integration again, and they thought data's already there. I had a lot to do, so my report development and updates were perceived as very slow by the users. So they were frustrated because they also thought, hey, it doesn't take long. And to them, sometimes it seems like I was not prioritizing their requests, but I was actually working on them. It just took longer, and they didn't understand why. And for me, obviously, it was a very intense time because I for sure wanted to fulfill their expectations. But this setup here, that really didn't make it easy to deliver on time, on their time expectations. So this one, at this point in the presentation, one term we need to talk about, which is data lineage. In case you haven't heard of that, I've copied here a definition, which says that data lineage is the process of tracing and visualizing the flow of data from its origin through various transformations and systems to its final destination. It documents where data comes from, how it changes, and where it ends up across multiple tools, pipelines, and business processes. And when I first learned this term, I thought, okay, why do I need to do some kind of diagrams to document the flow of data? But I very soon learned that it's not just about documentation. Data lineage is, from my point of view now, a strategic enabler for effective and scalable report development. Because if you don't have such a mess with all your data flows and connections that I did, it gets much easier to implement changes, to maintain the solution. And even though I didn't know the term yet at that point in time, I had a massive problem with data lineage. And because my architecture just grew beyond its capabilities with this setup. And luckily, I had the point where I realized, okay, something needs to change. And I came up with a solution, and this is actually one of the presentations I did to my management looked this pretty much like this slide here, that we need to have some kind of magic component in the middle. So that the data integration would be handled in one central location rather than individual reports, and go simply to streamline report development for greater efficiency, reduce the maintenance effort, and standardize KPI calculations and definitions across the report to ensure consistency. And by the end of stage 5, it became clear that this was no longer just about Power BI, which is originally a visualization tool, but I was building a data platform. And fortunately, I wasn't the only one. So many others were also pushing the boundaries of what's possible with Power BI and what it was originally meant to do. But luckily, Microsoft noticed the shift, and instead of losing assets, these advanced users, they responded by creating Microsoft Fabric. And there, they bundled different existing offerings, added new ones to also not just have this visualization layer, which is Power BI still the main purpose, but also have support this with a solid data management solution as a foundation. And this allowed me to also grow beyond reporting and to build this kind of robust data management architecture, but all in a similar and familiar ecosystem, which we will see later. And with that, this was my the short story of how I realized came from this BI self-service setup as a student, realizing that we need a data platform, and then made the decision to switch to Microsoft Fabric. Before I share my Microsoft Fabric migration blueprint, do we have any questions in the chat?
No questions yet, Max. I just posted in there to remind people to drop them in, but no questions at the moment.
Okay. Yep. Maybe it becomes more clear what this impact this development had on the future solution. So if you have any questions later also to this part of the presentation, just put it in the chat and we'll have another question element later. Good. Yeah, and in this second chapter, I will walk you through the migration process step by step that I did and share the key decisions that shaped my new architecture and also how you can build yours. Before I dive into the details, let's have a look at the high-level overview of the migration process. We're going to start with looking at and defining the main architecture structure, which we're going to use, and then later, build and clarify and develop. We will have, I will explain later what a module is, different modules in that. For each of the modules, we will have a look at the data model. We will also then implement this data model using data flows, schedule them with pipelines, and migrate the reports and permissions and so on. To understand or to be able to build the structure of the data platform in Microsoft Fabric, I followed the medallion architectural pattern, which is a layered approach to separate raw, cleaned, and created data. And each of these layers serves as a specific purpose and builds on the one before it. So the first one, obviously our source systems, whatever this might be, could be business applications, some Excel kind of setups that we see very often in Power BI, also some web sources, and even generated tables, whatever. Then when we transition to the bronze layer, where we have the raw data ingestion. In this layer, we store unprocessed data exactly as received from the source systems. We apply no transformations, so that the data is still often messy and inconsistent. And when we have the data load is typically partitioned by the ingestion time or the source system. And this layer acts as some kind of archive to for traceability and recovery. Second is the silver layer. When transitioning or loading the data from the bronze layer to the silver layer, we apply all the business logics, joins, filters, and validations. The data is standardized in terms of formats, codes, namings. A good example is a date format or country codes that might vary from system to system. And we also have error handling or add more information through calculated columns. And this layer then becomes the foundation for probably or possibly multiple downstream use cases. In the gold layer, we then have highly structured data, which is aggregated and tailored for business needs. It is designed to match the reporting structures and support the KPI calculation. So we're much closer to the business users that we have than to the source systems. It might contain summary tables and dimensional models. Talk about this in the next phase. And it's optimized for the use and consumption by BI tools like Power BI. And with having these different layers, I'd like to especially highlight this traceability. So when we see in our reporting some kind of inconsistency that users would like us to follow up, in Power BI, it would, in the initial setup, probably me going into data flows, waiting for the different previews of the results to be loaded, and then going back that data flow to see how the data was received by the source system, what happened in between, and how it was then loaded or made available to the reports. Here, if we, for example, want to check if an inconsistency was caused by the source system or by our transformations, we could simply compare the data in the bronze and silver layer to find out if this is coming from the source system or caused by our transformations. And with this structure in mind, let's go to my decision log on how I built this fabric architecture. As you can see here, we have our three layers, and in each of the layers we have one slot to fill with the data storage object. And between each layers we have obviously kind of movement elements, called movement, but this is ETL activities that we have in between. For the data storage, we have two existing objects from Power BI, which are the semantic model and data marts. But Microsoft Fabric, as said, added a bunch of new data storage types. I will not go through every single type, because you will definitely also be able to have a full session just on the storage types and then another session on the movement types. And it always depends on your setup, which one is the best. Same for the movement and transformation types. Here we have some new ones. The data flows that you see in green are the Gen 2 data flows. So Microsoft released a new type of new generation of data flows. When it comes to my decision, I have decided to use lakehouses as the storage objects for each layer and data flows for the movement part in between the transformations. The reason for that is that I was coming from a Power BI setup, so I already used Power Query a lot. And the lakehouses, they offer the benefit that you have one SQL analytics endpoint, so you can query the data very easily in each of the lakehouses to do some checks, look things up, and so on. But you're also able, and this is one aspect that I had in mind back then, to be able also to apply machine learning's notebooks, allowed to connect notebooks to them to do some advanced analytics on each of the layers. Then we have for the storage in the gold layer one semantic model, which also help to apply or reuse existing work that we have already done in the Power BI phase. For the movement part, as mentioned here, data flows, and these data flows allow to reuse my existing data flow code. For sure, I had to rework it a bit, but the foundations were already there with my previous Gen 1 data flows that I've already explained. So this here was the setup that I've decided to do or to go with. This is here the final version, and it's easy to explain this in a couple of minutes. My initial setup, I had two lakehouses and then the warehouse, just the warehouse in the gold layer as an example. Turned out to be not the ideal way, because then I had an issue with rollover security or implementing that. Would have been possible for the warehouse, but I then realized that having three lakehouses is a better decision. So don't be frustrated if this changes. This happened to me multiple times. Just make sure that you make intentional decisions. And your setup might even look completely different. As you see here, the different components. I would like to highlight a setup that's if you take a look at the legacy system, if you would, for example, migrate from a SQL Server environment, then maybe a warehouse where you work more with TSQL and store procedures to do the transformations might be a setup that fits better to existing architecture, but probably also to your team's capabilities. So don't just focus on the technical part, but I think also the available knowledge and capabilities within your team's organizations are also a key reason for deciding before or against one of these components. And the other thing I would like to highlight is that Microsoft recently introduced SQL databases as an object type in Microsoft Fabric, which are, I think, still in the beta phase, but this is also a new part. And then with Event House and KQL databases, if you look into real-time data. So once you've defined your main architecture structure, let's summarize this phase. It's about implementing a medallion-based structure to manage data storage and transformation effectively. And if you have some kind of diagram that I showed before, this is a valid output. Doesn't necessarily need to be in a more detailed level. At least it was not when I finished this stage. Let's have a look at the next stage, data modeling. Here you can see, we first need to talk about some data modeling techniques. And if you started like I did, you probably started with a flat table. So this will be here, this revenue reporting will be our case study for this session. Let's assume we have a revenue table that contains some country, sales territory, sales manager information, but also product details, customer details. For sure, if you do some business management reporting on financial KPIs, always the date or some time dimension important, and then we have the actual revenue numbers. Having a flat table is usually, from my experience, how people start in the self-service BI stage. And there's nothing bad about that, because this made reports or building reports in Power BI easy. And even later, it can make sense to keep this flat table pattern. Especially if you have, for example, a one-to-one relationship between data source and report, or the dimensions you don't need to have from the data source, don't need to integrate this with any other system. And the data size, the size of your data set is still manageable and shows a good performance. It can still later make sense to build single reports on a flat table layout. But especially when you integrate different data sources, it definitely makes sense to look at a more advanced schema. And one of them is the star schema, which you can see here from the layout, how it got to its name. Here you can see that we separated this into the tables, or the flat tables, into multiple tables, separating between fact and dimension tables. The fact table in this case is the revenue table. So you will see that it contains our fact. In this case, it's just the revenue. Fact usually something you can count, or a value you can sum up or aggregate in some way. Most often a number. And here it's the revenue. To this fact, we add dimensions, and these dimensions, they provide context information. In our case, it's the sales territory, the product, the customer, and the date. And then we have different tables per dimension tables. And in this case, our sales territory has an ID to identify it. It's a unique identifier, has a name, country, and a sales manager that's overseeing this territory. And with this setup, we are able to reduce the size of our data set, and we are able to increase the consistency. Because, for example, if I want to reassign a sales territory to another sales manager, in this case, I would only need to be required to change the one entry in the sales territory table, while here I need to be required to make sure that for in each of the rows where we have this territory, I need to update the sales manager. However, as you can see here, for example, within the country and the sales manager, this is not yet in a normalized format. This can be achieved by the Snowflake schema. But I have to admit, I may need choosing the different tables to show how it's got its name as a Snowflake. For example, we could drill down the sales territory and have us introduce a separate country dimension, which gives them the country name, for example, the local currency and the continent it's placed on. And if we would complete this snowflake schema, we would get to a normalized table structure. And in my case, as the snowflake schema, yeah, we would have a normalized structure that is 100% consistent and also limit the size of your data set. But it makes creating reports quite complicated because you have to, you need to have the different relationships in mind when populating the visuals. So I've chosen as a compromise the star schema for my reporting system, which is also the recommendation from Microsoft. Let's have a look at second part of the decision log and have a look here at the migration tracker, which is one of the most powerful tools I've built during this migration. One of the two most powerful. Here for each of the phases, I have some general tasks. And here the first one is design a data model and create entity relationship diagram. How I did that is I took a look at my flat table and first identified the different tables that I need to have, which in this case are revenue, sales territory, product, customer, and date. You don't need to identify the different fields that you have in their attributes yet. Just create this overall structure. Next step would be documenting the naming conventions for tables and columns. So always, create some rules on how you want to name tables and columns. Definitely makes sense. After that, now that we have our tables identified, we can start on and expand this tracker by adding the different tables. And for each of the tables, we have then 3 steps, and which we will then can mark as done, in progress, or to do, to always know what we've already done, what's completed, what we or our teams are working on, and what are the next steps. And for each of the tables, you first have a look at the attributes. And this will turn this overview into the detailed version of your data model diagram. For example, here, I've then assigned to the sales territory, country, and sales manager to this sales territory table. But you might also have new dimensions or new fields that you think, oh yeah, this might be helpful to do this right away. For example, having a country, the date, not using Power BI's default date hierarchy, but you can also add a date, a month, a quarter, a year. For example, then having a quarter as Q1, Q2 as a text format as an example. So you'll be able to identify new fields that are helpful for the reporting. Once you've identified that, it's important to think about the source and the mapping. If you think about 2 business applications, whether it be let's say the ERP system or the CRM system, we will have both of them will have some kind of country information with country code, country name, some kind of hierarchy. So you have to decide which one you're going to use, or if you want to say, I want to have a combination of both, how you implement or integrate them. And then define, if you say I'm going to use the countries in the CRM system as my leading source for this dimension, make sure in this mapping stage that you have a plan on how to translate the ERP countries or country codes, country names into the ones from the CRM system. Last but not least, documentation. I know this isn't fun, but it helps later on. If you, for example, give a description to each of the fields and also maybe add a subject matter expert from the business who could help you answer questions on these. Once done, let's summarize this phase. This data model phase has the purpose to design a clean and scalable data model using the star schema for each module and form a unified data galaxy schema. Module galaxy, let's quickly talk about that. To structure the data model in a scalable and maintainable way, I used some kind of modular approach with this galaxy schema. The galaxy schema is the collection of related star schemas that share a common dimension. So when you have not just one fact table, but multiple, and there's at least one dimension that's shared by 2 or more fact tables, you have a galaxy. And in my case, each reporting topic, for example, sales or revenue, customer activity, support tickets, is modeled as its own fact table. And this is in a module in my approach here. And then they're connected to a set of relevant dimension tables. So each module has its self-contained star schema, but they all form then the galaxy as our overall systems. Having this approach makes it or reduces the effort over time, because if you were working on your 5th fact table module, you will probably be able to already have some of the dimensions defined and loaded available from previous modules, and you can just reuse it, just have to build the relationship. Let's have a look at data flows in the third phase. Second within the module, third overall. Here, Microsoft introduced a new movement type, how I've called it previously, a new generation of data flows. They bring some value added, like Git integration, autosave, and other improvements or new features. Autosave sometimes is an improvement. But the most important one from my point of view is adding this data destination, which you can see here. And this is just a visual presentation of the transformation that we do, also a new feature. So we can finally have in data flows not just the extract and transform, but also the full ETL capabilities by adding a data source where then the final tables are loaded to, which is a very powerful function that we're going to use. However, if you just worked with Gen 1 data flows so far, as you can see, the interface and behavior is very similar. And so you will be able to quickly learn how to use Gen 2 data flows. How are we going to use them? Again, data lineage, and this here in a more intentional way, because before I built that, I spent some time thinking about it. Here we see again our structure of the source system: bronze layer, a silver layer, and gold layer with our lake houses that we've defined. And each of them obviously contain some tables. Each table is then loaded by a data flow. And go to our case study. For sure, we know our 5 tables we need to have in the gold layer, but then we need to think about how can we achieve that coming from the source systems. Let's say we've loaded the revenue information and the customer from our ERP system. My naming convention is that the data flows start with a DF, tables with a TB, and then the BR and the other tags here to identify the layer they are serving or part of. In this case here, this will be loaded from the ERP system. We also have this other data flow where we have some Excel files for the sales manager assignment to sales territory, we load maybe country dimension from the web, and a date table that we generate within Power Query without loading from the source system. And then what typically happens is that we then combine and join multiple tables and using the silver data flows to get this then transformed, cleaned silver tables. 2 exceptions that I've put in here. First one is if the date table we generated and it comes in the format that we need to have in the silver layer, so no transformation from bronze to silver layer. Data flows, and this is one advantage over warehouses, allow to simply mirror tables from another lakehouse. So we can simply say, okay, we want to have our silver layer, and please just let it or mirror the one in the bronze table. So we don't have to think about synchronizing them on this, just we always show the same results. If you have, and this especially, or is most important in my experience for the fact tables, if you have for the same revenue dimension, 2 source tables, and in this case, I have, let's say, the direct sales and the indirect sales via sales partners and resellers as 2 separate bronze tables, and they both require a lot of transformation. For traceability reasons, it might make sense to still keep them separated in the silver layer and then combine them using the gold data flows. And also this setup here changes. So let's have a look at the migration tracker. First, we identify the data lineage by identifying bronze and silver tables and group them into data flows. As you've seen, the bronze data flows usually are, the grouping happens based on the source system. And then for the silver and gold data flows, I do this based on the target output table. For sure, naming conventions, in my case, DF, the prefix for data flows, TB for tables, and then BR for bronze and so on, to give more information and to also sort them in the workspace. For each of the data flows, we then list the tables and we implement them one by one. And yes, it happened multiple times that I started in the middle of the implementation. Oh, maybe I need to rearrange it, have other data flows, move tables between data flows, to have it because it better fits into one of the other data flows compared to output or refresh times. It's easy to explain this, in this case study, but there are some iterations until you achieve a structure that's you feel comfortable with, which is absolutely fine and part of the process. To summarize this, data flows automate the data movement between the Lakers layers using data flows and validate results against legacy system data. The validation important step. Once you've finished the data flow, make sure that you compare it to the legacy system to make sure that the output is the same. Now we have our data flows, and I bet that you don't want to refresh them one by one. But luckily we have pipelines to orchestrate that. Pipelines are a new feature or object in Microsoft Fabric that didn't exist in Power BI. You can simply orchestrate and build a flow of activities. This could be, in this example here, is setting a variable running data flows. So we can trigger data flows, which is the activity part that we are most interested in. And even send notifications as emails in Outlook or Teams. As you can see, you can link these activities by based on the output of the previous one. Skip, if this was skipped, if this is completed successfully, run into an error, or was completed, no matter what the output or success rate was. So this we'll be using to orchestrate the data flow refreshes. If you decide in your setup to go with stored procedures, with notebooks, with copy data activities, you will also be able to use them or trigger them within pipelines. And pipelines can then be scheduled as data flows on like daily, weekly basis, and also be triggered manually. In our case, let's have a look at the pipeline for the ERP system, PL_ERP, PL obviously pipeline. If we would need to do that manually, would mean that we sit there probably during the night. I don't know when your refreshes or loads are scheduled, and refresh first the ERP data flow. Wait until this is done, refresh the revenue silver data flow, and also this goes into the customer dimension. So we need to also schedule the customer silver data flow. Wait until one of these is finished, and then manually start the following one. You can do that if you have 1-2 data flows. If you have a bunch of them, this is no longer manageable from an effort perspective. So we use then pipelines to automate this and just say, okay, at the start when the pipeline is triggered, start with the first bronze data flow. Once this is done, make a split to start then these 2 streams here. And once the silver data flows are done, you can then start the gold data flows and so on. And here it's important to take a look at how many pipelines do I need and which table should be covered by them. Here, also recommend that if you refresh the bronze table, make sure that the information flows through all data sources. Data flows to the gold layer, because, for example, if you have the customer information goes into revenue into the customer dimension, if you refresh just the revenue stream without the customer dimension, you could have cases where the new customer created and you have this customer number in the revenue as a foreign key, but you don't have a matching primary key in the customer dimension because this string here just wasn't refreshed. Other things might be considerations, might be refreshing the refresh times. So here we first need to identify the necessary pipelines to orchestrate data flows, and then document naming conventions, and then just refresh the pipelines, implement the pipelines one by one. To summarize, we leverage a Maxwell Fabric pipelines to scale data flows, enabling efficient and automated refreshes. The reports are quite easy. There's just one thing that was important to me because I wanted to keep my existing role of security in DAX. And by default, Microsoft Fabric can connect or connects when a user connects to a report. It will use the single sign-on SSO information, meaning the user's credential, to access the data semantic model, and then the gold layer, which is in our case here the gold lakehouse. However, in RLS rules in the data set, semantic model, would be defined in the semantic model, and they need to have a consistent access to the underlying data source to work properly. We maybe don't want to give our users access to the entire gold lakehouse, so we need to make sure that there's one fixed identity. And you can do this in the data semantic model settings, go to single sign-on, and switch this here to create a new connection. You can either use your personal credentials as a developer or create some kind of system user that you use. And by that, we can make sure that the semantic model always queries data from the gold lakehouse with a predictable identity. And with that, the RLS existing as a node from Power BI can be applied to the semantic model. When migrating the report, these are the last two sections of our migration tracker. We first have to develop measures and define which measures do we need. And if you have a bunch of them, it might make sense to group them in folders, naming conventions as always. And in my case, I've decided to need, for example, a total revenue measure. We need to implement that and also write documentation. Documentation is especially important to mention all applied filters. Then we can start by identifying the reports that need to be migrated, and then migrate them one by one. In the migration phase, you simply connect the new semantic model to the existing report, and visual by visual exchange the fields that we have used from the old semantic model and use the ones from the new ones. Once all visuals are updated, we just remove the old semantic model, and our report is connected to a new data platform without the necessity to completely rebuild it. Quality control, I have it as a separate step here, because for me it's always important to make sure that the behavior and numbers and fields and like list options in the slicer are the same as in the legacy system, because up to this point our users do not see any value in this migration, because they will later see it when we are able to have more consistent data, when we are able to ship updates faster. But it's important to not lose that trust in our system at this point in time when we forget something during the migration and ship defective reports to them. That's because after the release, I also already have here the kind of hypercare step, which is not an activity that you actively need to do, but pay attention if there's feedback, react to it instantly, as mentioned, to make sure that we do not lose trust from our users. And to summarize this, yeah, we've established a new semantic model and connected the existing reports to the centralized data sources, and have then also centralized business logic in our reporting, defined in our code layer. And this process we can then do module by module, always have this migration tracker to keep track of where you are, what are the next steps, have the data or further develop the data model. So for example, entity relationship diagram and the data lineage diagram, and then migrate module by module. And this way, you will then sooner or later be able to have all this solid data management foundations. My two key learnings out of that for the Power BI phase, I've already touched this a bit, that self-service success often hides architectural debt, which is not a problem at the beginning, because this way you are able to learn when it comes to technical implementation, to develop your personal skills, but yeah, while still showing that you were able to deliver real benefits to the business by automating tasks and providing new insights. However, it's important to recognize when your BI stack becomes fragile and proactively decide when it's time to scale through centralized models and governed architecture. Because at some point you're no longer in the self-service phase, but you start building a data platform, and you need to recognize this step and then act accordingly. Learnings from the migration phase is that building a scalable BI architecture isn't just a technical skill or technical task. One of the two main tools, as mentioned, is the migration tracker, which is purely project management. And it requires strong project management skills and a deep understanding of data architecture. And then, as said, the discipline to make intentional decisions. For sure, what I've explained sounds easy, but it was a lot of experiments, trying things out, completely getting frustrated because you had to draw this data lineage diagram again with all these little boxes, because you've changed the layout again, because you had a new insight, new learning, and wanted to apply that. But I think it's important to make intentional decisions to not directly create debt during this migration phase. So it's important to make the decisions intentionally. So looking back, what started for me as a small student project to automate a few Excel reports became the foundation of something much bigger. Over the time, my technical challenges turned into architectural decisions. And this very first report that I've showed you turned into the entire reporting platform. And for me, this solo effort became a team. So today I lead a group of data analysts and progressed into the role of lead business intelligence architect. And I am able to drive now this BI setup as a professional data platform at scale. And so before we move to the question section, I would like to give a special thank you to my mentor, Konstantin Klein. Thank you very much. Your guidance and encouragement have not only helped me to reflect on my development, but also define this direction of this session. Thank you very much. So this was my journey, and now it's time for you to shape yours. Always keep asking where you are, where you're going, and how you want to get there. And if you have any questions, want to share your own experiences, or just want to connect, feel free to reach out to me on LinkedIn. Microsoft Fabric is still evolving, so just like our roles as data architects. And I'm always happy to exchange ideas, learn from others, and on their data journeys. And always remember, we don't just build data, we just don't move data. We shape the systems that shape decisions. So always don't build the systems just with your today's needs in mind, but for tomorrow's potential. Thank you very much.